both can be used, but at different times of the attack. It's actually really cool the way it works. Because me personally, I kind of like that my body can do this stuff. I'm a very firm believer in letting your body build its own defenses. Okay? Now, if it has to be the first one, the cell-mediated, it can use cytotoxic T cells. Wait a minute, where was the T cell at? In the lymph node. How did it get activated? An antigen-presenting cell, the macrophage, that consumed the pathogen and pushed a little piece of it to the membrane and brought it to the lymph node, to the T cell, and presented it. And that activated T cells. Now, if it's a cytotoxic T cell, cyto, cell, toxic, that means it's toxic to a cell. Helper T cells. Well, I've said several times, T cells are going to need the help of B cells. So when this antigen, when this pathogen, this antigen, gets presented to a T cell, T cells can call it these. They can actually produce them. And then it's going to need B cells. Why? B cells can produce the antibody needed. T cells can't. Okay? T cells have to call it B cells because B cells can make the antibody. We can also activate macrophages. Come here and eat this piece that I've caught. Dendritic cells. Almost any cell of the immune system. Because we have now activated the actual immune system. You're going to see in your textbook that it's going to talk about something called a histocompatibility complex. All it is, proteins on the surface cell surface to help recognize that it's, or help to say, this is a foreign cell, attack it. We do not want our self cells to be attacked. We only want the foreign cell. It'll talk to you about MHCs 1 and 2. 1 would be on any cell that can have a nucleus. 2 is where we have to use APCs, an antigen-presenting cell. Chemical agents can be used to attack the pathogen. We can use those perforins, those granzymes, those interferons, and then tumor necrosis factor, which is for cancer. The mechanisms can be make the cell burst open, consume the cell, the phagocytosis, and apoptosis, the cell bursts. Apoptosis is where the cell just bursts and dies. And then, let's make a memory cell. the T cells. And this is an idea of something that gets to happen. Kind of cool. Yes, no, maybe. So, we have a cell, a pathogen, that has invaded. It gets recognized. In this case, the macrophage is recognizing it, and it consumes it and tries to kill it. But there's too many, or it's not one that it's, whatever the case might be, that macrophage now had to become an antigen-presenting cell. Do you see how it kind of pushed little pieces to the membrane? So, this antigen-presenting cell finds its way to T cells. In this case, the T cell had a memory of whatever tried to invade. So the memory T cell, which had just simply been sitting and waiting, can attach. But in the meantime, I don't have enough of these because all it did was create a memory. This memory T cell now has to have some help. It has to form enough cells to destroy the invader. Is everybody following me? In other words, if the body only created 20 memory cells, but we're now invaded by 500, that's not enough to fight the pathogen. So it says, woohoo, let's duplicate. We need to get some help going here. Since this one is based on cells, that T cell went into mitosis, generated these killer cells, and the killer cells are able to attach to the pathogen and kill it. Now, this one was cell mediated. T cells, called up helper cells. T cells duplicate, make the killer cell. Killer cells attack. What is not being mentioned here?
B cells.
The B cells. Why? My B cells generate antibodies. In cell-mediated, we are strictly dependent on cells. So the T cells, the helper cells, making more, becoming the killer cell, attacking. There was nothing about an antibody attaching to the antigen. B cells were not needed. Does that make sense? Okay? Can you think of why any of this might be clinically significant? Do you think in your chosen profession you might come across sick people? Seriously. That's a given, right? Marlisa?
I was going to say, maybe it'll tell you different, like if it's a viral infection or bacterial infection.
And therefore the reason they might be on the medication they're on. Yep. Why it could maybe be having an effect on some of their lab work. Why it might be having an effect on their fever, their body temperature, their lethargy, everything. So, I have my cell-mediated response. This is now specific. When that memory T cell, in this case right here, because a memory T cell was already formed, that means the body had already fought this pathogen one time before. But in the case of where that's not the case, where it would be something totally new, this would simply just be a T cell. And once the process was done, over here coming off to the side would be formation of the memory cells. So while the other ones are going off to fight the battle, the other ones would go and migrate to a lymph node and become the T cells, the memory cells. Okay. Take a break, be back at 9:30.